Hello, Namaskar to the online classes of Aditya Computations. Today we will start this chapter number 15 of 10th standard probability. It is also important and useful for 9th standard. So the meaning of probability is chance, जिसको हिंदी में हम बोलते हैं संभावना. There are two types of probability. One is empirical or experimental, where different kinds of experiments are performed. Say for example, if coin is tossed 10 times and the results are like 6 times it falls head and 4 times it is tails. So these are the results that we've obtained by performing experiment. So that kind of probability, if we have obtained the probability using this data, then it is called the practical, experimental or empirical probability. The other type is theoretical probability, or it is also known as classical theory, classical probability. In classical probability, we are looking all the possible aspects. So there are two probable outcomes in case of this tossing the coin, that is heads or tails. Either of them will be there. Now let us look at some of the histories which can be important for you guys as a part of MCQs or single one word answer in one word or so like that. So history. The origin of the probability began in the 16th century. An Italian mathematician J. Cardin wrote a book named Game of Chance, in which he introduced this science or this maths probability. The significant contribution was made by Pierre Simon Laplace, and he wrote a book of Theorie Analytique des Probabilités. This is a French name, so he wrote this book and he made a significant contribution of this probability. Fourth, the formula to find out the probability, the value of probability is this: PE is equal to number of favorable outcome divided by total number of outcomes. Outcome means whenever we perform an experiment, the results are also called the outcomes. P stands for probability, E stands for event. Event means whatever is asked to you. Say find the probability to select the red ball out of the box, or find the probability that the sun rises in the east. These are the events and we have to find out its probability. The value of probability, there are two specific events, that is impossible event and certain or the sure event. Value of probability for impossible event is 0, because according to this formula, say for the sake of example, we take an event that sun rises in the west, opposite to that usually does, west. A probability to rise the sun in the west will be 0. Why is it 0? Because if we take 10 observations, 10 consecutive days, if you look at the sun where it is rising from, so we will find 0 days that sun rises in the west, because sun never rises in the west, it always rises in the east. That's right. So therefore there will be 0 observation or the 0 outcome out of total 10 days. No day sun will rise in west. Therefore the probability will be 0 upon 10, that is 0. The second one is certain event. If the event is sure to occur, like the sun rises in the east, then its probability will be 1. Why? Because all 10 days the sun will rise in the east. So our observation will be 10 by 10. 10 cut, therefore we'll get 1. Or if it is neither impossible event nor certain event, then the probability lies between these two. It will be between 0 and 1. So other than the sure or the impossible event, the probability lies like this: 0 less than probability of the event less than 1. If we exclude this impossible and certain event, if we include that, the final, in short, for any event, the probability will be 0 less or equal PE, that is probability of event, less or equal 1. So less or equal indicates that probability can be 0 for impossible event and probability can be 1 for certain event. Next, point number 5 is elementary event. What is called elementary event? If there is only one outcome, then it is called an elementary event. Say for tossing a coin, there are two actually events that can occur one at a time, simultaneously. Both the things do not occur simultaneously. Either heads is there or the tails is there. Okay, so heads and tails are two elementary events right? So as a whole, we can say that there are 2 elementary events associated with tossing the coin. Say in the case of dice, there are 6 numbers, 1, 2, 3, 4, 5, 6. So there are 6 elementary events in case of the dice. Point number 6, sum of all elementary event is 1. See, if we toss a coin, any one of these will fall for sure. Either it will be heads or tails, but it is sure that one of these will occur. So probability of this plus probability of this together makes it 1. So sum of probabilities of all elementary event is 1. 7th point is complementary event. What is complementary event? See, we have seen many events, say heads on the top, or number 6 on the top of a dice, or sun rising in the east. There are so many events. But what is complementary event? So complementary event means not occurrence of that particular event. That is called complementary event. Right? That sun rises in the east is event. Then sun does not rises in the east is called its complementary event. Okay? Which is represented, and the complementary event is represented by PE bar. You can see the dash on the top of this. It can be calculated just using this formula as well. PE bar is equal to 1 minus PE, or you need to remember it like this: PE plus PE bar. Occurrence, probability of occurrence, and probability of not occurrence altogether is equal to 1. Means either it will occur or not occur. Any one of these is true. That's why it is 1. Let us understand this probability or this theory in better way just by using some kind of numericals. We have studied in 9th standard about the experimental or the empirical probability, where the experiment is performed and results are given. On the basis of these results, we need to find out the probability. So here, let us take an example of a coin which is tossed 10 times, and out of this, the results are like this: heads came 4 times, while tails came 6 times. Let us find out the probability of these 2 events given to us, that it is heads or it is tails. We will use this formula: probability of event is equal to number of favorable outcomes upon total numbers of outcome. Here, total number of outcomes are 10, out of which there are 4 heads and 6 tails. So let us find out the probability of this event, first event, that is, it is heads. So probability of heads, A, is equal to number of favorable outcome 4 divided by total number of outcome, which is 10. So it is 0.4. Similarly, we can find out the probability for the tails. PB is equal to 6 upon 10. Why 6 upon 10? Because there are 6 tails and total numbers of outcomes are 10. So it is 0.6. Probability of complementary event of this E, A. Complementary event means PA bar, which is equal to 1 minus probability of that particular event. So it is 1 minus PA. 1 minus probability of this A, event A, is 0.4. So 1 minus 0.4 will be 0.6. So probability of not occurrence of this event, that it is heads, is 0.6. Similarly, the probability of not occurrence of tails, event B, is 1 minus probability of occurrence of B. 1 minus 0.6, which is 0.4. So we have probability of A, which is 0.4, probability of occurrence of B is 0.6, probability of not occurrence of A is 0.6, probability of not occurrence of B is 0.4. Remember, bar means not occurrence of that event, which is called complementary event. Let us confirm some previously written results. That is, sum of all probabilities of the elementary event is equal to 1. So here we can see probability of event A is 0.4 and probability of event B is 0.6. These are the 2 elementary events whose sum is 1. Number 2 is probability of any event or plus probability of its complementary event. The sum of these 2 is 1. So probability of A plus probability of A bar is equal to 0.4 plus 0.6, which is equal to 1. So these are the 2 results which we have confirmed, that PA plus PA bar means whatever number of elementary events are there, the sum of probabilities of all of them will be equal to 1, and the sum of the event, probability of event and probability of complementary event is equal to 1. let us take an example from standard 9 that 11 bags of wheat flour each marked 5 kg actually contain the following weights of the flour in kilograms. So this is the sum and here are the weights of the flour. And they are like 4.97, 5.05, 5.08, 5.03 likewise. Okay, let us find out the probability. We are asked to find out the probability of having the weight flour, having bag of wheat flour more than 5 kg. So let us find out the probability of this event. The formula to find out the probability is number of favorable outcomes divided by total numbers of outcomes. Here, let us find out how many bags contain more than 5 kg weight. So they are 1, 2, 3, 4, 5, 6 and 7. See, 5 is not more than 5. 5 is not more than 5. 4.98 is less than 5 kg. So we need to find out more than 5 kg. So here are 5.05 which is more than 5. 1, 2, 3, 4, 5, 6, 7. So there are 7 favorable outcomes. 7 outcomes which are favorable to our event. Divide by total numbers of outcomes. In question it is already given that there are total 11 bags. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can count it as well. Okay. Here's one more example from 9th standard. You can see this. It's given over here. You can see. So it says 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the numbers of seeds which had germinated in each collection were counted and recorded as follows. The table is given over here. You can see this. We are asked to find the probability of the germination of the seed. How many seeds germinated? It is already given. In first bag, 40 seeds germinated. In second bag, 48 germinated. In third bag, 42 germinated seeds. Fourth bag, 39 seeds germinated. And in fifth bag, 41 seeds germinated out of 50 seeds. Okay. So data are given to you, and we are asked to find the probability to find out how many bags contain more than 40 seeds. Second, 49 seeds in a bag. Third, more than 35 seeds in a bag. So let us do some calculations and using this data which is already given to us. This is the experimental or the empirical probability. This is the sum. I'm just doing it right here. First, probability of first event, let us say PA is equal to, we need to write down remember the formula, that numbers of favorable outcome divided by total numbers of outcomes. This is the formula which we need to keep in our mind. More than 40 seeds in a bag. So how many actually of this 1, 2, 3, 4, 5 bags contain more than 40 seeds which got germinated? So they are second, third and fifth. Means there are 3 bags from which more than 40 seeds got germinated, right? 48, 42 and 41. Out of how many bags? Total bags. You need to look at the number of bags. Out of 5 bags, 3 bags got more than 40 seeds germinated. So its probability is 3 upon 5. You can further calculate it if you want. 3 upon 5 multiplied by 2 upon 2. Why am I multiplying? Because I want the decimal numbers. So it will give us 0.6. Even if you don't do this, it's okay. This is your answer. Second probability that they have asked us is, second event is 49 seeds in a bag. So actually, if you look at this table, there is none which contain 49 bags, right? 49 seeds got germinated. So 0 upon 5 will be the answer, means 0. It is an impossible event because in table, no bag contains 49 germinated seeds. The third one is, let us take probability of that event C. More than 35 seeds in a bag. So how many seeds got germinated? So more than 35 seeds means if you look at all of them are more than 35. 40, 48, 42, 39, 41, all of them are more than 35. So I will say 5 out of 5. All of them got more than 35 seeds germinated. Means this is a sure event. Right? Exercise 15.1, sum number 9. And the sum is like this. A box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be of red color, white color and not green? We are asked to find probability of these 3 events. White, and third is not green. Okay, so looking at the sum, how many red marbles are there? So there are 5 red marbles, there are 8 white marbles and 4 green marbles. So we can calculate it very easily by using this data given to us, right? So first of all, probability. Let us find out the probability of this first event, that the selected ball is red ball. So remember the formula for once again. Number of favorable outcome, or the numbers of outcome favorable to our event, divided by total number of outcome. How many favorable outcomes are there? So there are 5 balls or 5 marbles which are favorable outcomes. Out of how many? So 5 plus 8 plus 4. 5 plus 4, 9, 9 plus this, 17. So there are 17 marbles, out of which 5 are red. So the probability of selecting a red ball is 5 upon 17. Similarly, the probability of selecting white marble is 8 upon 70. And the third probability, not green. The probability of not finding this green marble is equal to how many not green are? How many marbles are not green? 8 plus 5, because 5 are red, 8 are white, which are not green. So 8 plus 5 are 13. 8 plus 5 is 13. 13 divided by 17. You can directly get the answer, which we did over here, can be replaced by doing this or by performing this calculation. Okay, let us take some special type of sums. There are coin wala sums, dice wala sum, numbers of days wala sum, areas wala sum. So various kinds of sums we will take. The first amongst them is coin wala sum, right? We will call it coin wala sum. So what if one coin is tossed? The results might be, the total numbers of outcome will be either it will be heads or tails. If 2 coins simultaneously or one by one tossed, the results or the outcomes might be like this: both heads, heads, tail, tail heads, tails, tails. So as a whole, there are 4 different combinations or 4 different outcomes that we can write. And in case of 3 coins, how can we write the total combinations for 3 coins? There's a technique. You need to write it down like this. First you selected heads and then you altered one by one. Heads, 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 tails. Then you changed tails, tails, heads, tails, tails. You can write down or select the same combination again for the 3 coins. But first 4 with heads and second 4 with tails. So these are the 8 possible outcomes for 3 coins. If 3 coins are tossed one by one or simultaneously, these 8 outcomes will be there. So let us look at the total numbers of outcome. For 1 coin, total number of outcome are 2. For 2 coins, total number of outcome is 4. And for 3 coins, the total numbers of outcome are 8. There are 8 outcomes. So what kind of question can be asked out of this? Question can be asked to you like, find the probability that at least 1 tails or 1 heads or something like this. So let us take tails. What at least? What do you mean by at least? At least means minimum 1 tail. We need to have minimum 1 tail. Say for these 3 coins, we will find out the minimum 1 coin, 1 tails. So is it okay? Minimum 1. Minimum 1 means more than 1, it's okay, but cannot be less than 1. So 1, 2, 3, 4, 5, 6, 7. Why we haven't selected this one? Because it does not contain even single T. That's why we haven't selected. So probability for this event will be equal to 7 upon 8. There are 7 outcomes which contains minimum 1 tails. But this doesn't contain, out of 8, 7 contains 1 tail at least. That's why our answer will be 7 upon 8. Probability of B for this event, say at most 2. At most 2 means maximum 2. Cannot be more than 2. Cannot be greater than 2. Hence cannot be more greater than 2. So let us find out the probable outcomes or favorable outcomes. Not more than 2. It should be 2 or less than 2. See, less than 2, more than 2, it won't work. 2 exactly, 2, less than 2 it's fine. Less than 2, 2, less than 2, less than 2, and 0 is also less than 2. There is no head. But 0 is also less than 2. We want maximum 2, not more than 2. So here there is only one which is more than 2. That's why here also the answer will be 7 upon 8. There are 7 probable favorable outcomes. 1, 2, 3, 4, 5, 6, 7 out of 8. Okay. So these are very easy sums. So now you can find out the probability of any damn question asked to you. Okay. Next type is dice balance. See, if one die is tossed, the outcome might be 1, 2, 3, 4, 5, 6. These numbers, actually it is represented by different dots as it is seen over here, right? So 1, 2, 3, 4, 5, 6. 6 different outcomes. So total numbers of outcome are 6 for one die. If there are 2 dice tossed simultaneously, right? So it can be written like this. Here's a table which can help to you, or you can write it like this: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay. Second, you change the first number 2, 2, 2, 2, 2, 2, and 1, 2, 3, 4, 5, 6. This is a combination. So these kind of combinations can be there. So 3, 3, 3, 3, 3, 3, 1, 2, 3, 4, 5, 6. And similarly 4, 4, 4, 4, 4, 1, 2, 3, 4, 5, 6. 5, 5, 5, 5, 5, 1, 2, 3, 4, 5, 6. 6, 6, 6, 6, 6, 1, 2, 3, 4, 5, 6. So 6, 6 are. How many combinations are there? That's right. 36 total numbers of outcomes that are possible for 2 dice if they are tossed simultaneously. Okay. Now, what different kinds of sums are asked to you? For this, what is probability that the number on the top is even, the number on the top is odd, prime, composite, multiple of? These kinds of questions can be asked. Or the sum of 2. In case of the 2 dice, sum of 2 is, or product of the number is something which is asked. So these kind of questions can be asked. Value, multiple of which we already have written in this case, less than, more than, or having same number. So these are the probable questions that can be asked to you. Here, even numbers. Which are the even numbers that we are getting over here? In this case, 1 dice. So even numbers are 2, 4, 6. So there are 3 even numbers out of 6. For odd number, 1, 3, 5. 3 out of 6 are the odd numbers. You can further cancel it, and the answer will be 1 upon 2. Prime number. Which are the prime number? 1 is neither prime nor composite. So that prime numbers are 2, 3 and 5. 2, 3 and 5. The number which has factor, only 2 factors, itself and 1, are called prime numbers. And composite number other than prime are composite number. Say 6, 4. 6 and 4 are composite number. So there are 2 composite numbers. So probability of that will be 1 upon 3. if it is asked like this, find the probability that the sum of the numbers on the top is, say, 10 or more than 10 or less than 10, value can vary, right? So sum of them, it is very easy to find out. The sum of the numbers is 10. So where are the combinations where you can find out the 10? So it is, it goes beyond this. 4, 6, 5, 5, okay, then 6, 4, if it is 10, exactly 10, then 4, 6, 5, 5, 6, 4. 3 options are there, 3 out of 36. Total numbers of outcomes are 36, out of which 3 are favorable outcome, which supports our event. If it is asked more than 10, so we might add 5, 6, 6, 5, 6, 6, somewhat like this. So various combinations are possible for the questions to be asked. Product on the number is, say, product on the number is multiple of 5 means what are the possible multiples of, what are multiples of 5? 5, 10, 15. But 15 cannot be there because 6 and 6 are the maximum numbers that you can obtain on 2 dice. 12 is the maximum number that you can obtain. So 5 and 10. How can you obtain 5? Total number 5? You know, the cross lines are given to you which suggests you the numbers. Total numbers can be 2, 3, 4, 5, 6, 7 up to 12. So 2 for 2. If we toss 2 dice simultaneously, number 2 can be obtained only in one way. That is 1, 1. 2, 1 times, 3, 2 times, 4, 5 times, likewise. You can remember it very easily. So there's a technique for this. So these are all dice wala. So the third type of sums that can be asked to you is of playing cards. In a deck of playing cards, there are 52 cards, total 52 cards, in which it is divided into 4 suits. These suits are heart, diamond, club, and spade. Their name, you need to remember the name: heart, diamond, club, and spade. There are 13 cards of each suit, out of which heart and diamond are of red colored, while club and spade are of black color, that you know. Okay. So total 13 cards, 13, 52 cards are there, out of which red colored card, heart and diamond, since they are red, 13 plus 13, it will be 26. And club and spade are of black color, 13 plus 13, they will accumulate to 26. Okay. The name of the card are like this. Starting from ace, the one number is called ace. Card of number 2, card of number 3, card of number 10. Then jack, queen, and king. These are the name of the card which can be asked to you. Then find the probability that the selected card is jack of black suit. Right? Like that. So, jack, queen, and king are face cards. Face cards, they are called face cards because face is printed. If you have seen the cards, or you can see it right here, the face is drawn over there. So question can be asked to you like this: find the probability that the selected card is of face card of red color, face card of black color, face card of heart, face card of, say, club, or ace, that the selected card is ace of any color, of any suit. Value of cards are like this: ace having the highest value, ace, then king is subsequent, Q, queen, jack, 10, 9, up to 2. 2 is the card having lowest value. Why am I saying all this? Because it may be asked to you, find the probability that the selected card, if one card is selected from a deck of 52 cards, find the probability that the selected card is having the highest value or the lowest value, that is 2. It can be asked to you. Okay, so any kind of sums can be tackled using this data. All the cards are given over here. Let's take a sum of card wala sum. It is in exercise 15.1, sum number 14 in textbook. One card is drawn from a well shuffled pack of 52 cards. Find the probability of getting the following. Number 1, a king of red color. King of red color. There are two different cards having red color, that is heart and diamond. So 2 kings which are of red color out of 52 means the probability of this event will be 2 divided by 52, that is equal to 1 divided by, that's right, 26. The first. Second one, find the probability that the selected card is face card. So how many cards are face cards? Jack, king, queen and king are the face cards. But Jack, king and queen are of 4 different suits. 4 3s are 12 different cards out of 52. J, Q, K. Jack, king, queen and king of spade, club, diamond and heart. So total probability will be 13 fours and 3 fours. So 3 by 30. Third is red face card. 2 criteria are given to you. It should be red in color and it should be a face card. Red color, there are 2 suits which are of red color, that is heart and club. Heart and diamond, sorry. And face card, J, Q and K. Jack, queen and king are of face card, are called the face cards. So J, Q and K of red, that is heart, and J, Q and K of diamond. Total 6 outcomes out of 52. So 6 by 52 is equal to 3 upon 26. Next question is Jack of heart. How many Jack of hearts are there? Answer is right, only 1. So the probability of that event will be 1 upon 52. One more question is asked that it's a spade card, spade. So how many spade cards are there? We know that each suit has 13 cards, right? So spade card, there are 13 spade cards out of 52. 13 ones are, 13 fours are, 1 upon 4 will be the answer. And queen of diamond. Find the probability of selecting a queen of diamond. How many queens of diamonds are there in a deck of 52 cards? So there is only 1. So probability of this event F is equal to 1 upon 52.